for now, we're going to load a network model using detailed morphologies. And you would not want to build this from scratch because it's very complicated, a lot of details. So again, under tutorials, go down to 2, the detailed cell network, and click on that. And it should load this all up. So in our cell types here, we can see that now we have 2 cell types. We've got a pyramidal cell and an interneuron cell. Let's click on the pyramidal cell and see what it's like in terms of sections. Oh, wow, soma, axon, and then hundreds of dendrites, apical dendrites. So this is a very complex morphology. Each one of these sections has its own geometry, its diameter, its length, its resistance, all that. And in this case, it even has 3D points. So this is morphologically laid out appropriately in 3D. And each section is going to have mechanisms. So for the soma section we were looking at, it's got some calcium mechanisms, an IH current, a variety of potassium currents, sodium current, passive currents, and so on. And if you click on any of these, then you can see what the settings are for that mechanism. We got 2 populations.
Sorry, Joe. Yeah. So maybe you can just illustrate how we would import one of these cells. So if you go back to cell types and just show that both of these cells come from Hulk files, and they were just imported using this method. So just to illustrate it.
So from here, this little arrow always clears a selection. So if you're on pyramidal cell, you can click unselect, and that'll clear it. Let's go plus for a new cell. And yeah, we can import a cell template from file. So these detailed morphologies, Python or Hoke, right, Salva, you can import from?
Yes.
And there are some already online, right? So if we click on absolute path to file, we click on that folder, then we get some of this stuff is already available in the cloud. And we've got a cells directory here with a few different cell types that you can use. And these cells come from here, Salva, is this correct?
Yes, so the pyramidal cell is the PT cell, which is pyramidal tract projecting from mouse, and the other one is the SRI cell, which is a cell from CA1, an inhibitory interneuron.
So yeah, so it's very easy to import cell models. Let's go ahead and let's look at our populations first. We got an excitatory and an inhibitory. The excitatory is made of the PYR cells. We only have 2 because it's highly detailed, and we each only have 1 core to run on right now. The inhibitory cell, again, just 2. So with cell types and populations, that's enough to create a network and take a look.
And Joe, maybe you can maximize your window because we see like a border with like some of the C's.
Oh, I thought I was supposed to just share. Okay, there you go. Is that
perfect?
Better?
Yes, thank you.
All right, and so yeah, we've got our detailed morphologies, which are a little difficult to see. I need to zoom in here. And, translate. And they all start as pink, but let's go ahead and change the colors so we can distinguish them. So for the E population, let's give it, I don't know, like a bluish color. For the I population, let's give it like a yellowish color. And yeah, so now we can see we've got 2 morphologically detailed pyramidal cells and 2 morphologically detailed interneurons. And yeah, let's go back to our edit just to see what else we're doing here. Synaptic mechanisms now, we've got 2, an AMPA for excitatory, a GABA for inhibitory. And you click on these and you can see these are just that XP2 SYN. You can do a lot of synaptic models with the XP2 SYN. GABA. GABA is, yeah, XP2 SYN again. And yeah, you can see this one is inhibitory. It's got a negative reversal potential, whereas the AMPA is excitatory. It's got a positive reversal potential. We defined our connectivity rules, E to I to E. Now we've got 2 rules. And these are going to have different settings. Stimulation sources, we're going to provide a background stimulation source. It's just a net stim with a firing frequency of 40 hertz. It's going to start right away at 1. And the targets, background to peer 1, we've only got 1 target set up. And based on the name, I'm guessing it goes to the just pyramidal cell 1. It targets the apical. It uses AMPA. These are all things you set. The conditions, it's targeting the entire excitatory population, so it'll hit all those pyramidal cells. For our configuration, we're going to run for 500 milliseconds with a 0.1 time step. Recording, we're going to record from the soma. We don't have any traces set in this yet, but maybe that's in the, that must be in the iPlot traces. So that's going to say it's going to record from 2 cells, cell 0 and cell 2. And any cell you set to plot in a plot, NetPyNE will automatically add it to the cells to be recorded. So you don't have to do it in both places. All right, so we've got an entire model we imported. We've seen what we've got set up. Let's go ahead and create it again. And this takes again, it's morphologically detailed, a lot of compartments in there. All right, we're back. So let's look at our analysis here. We got our 2D net plot with only 4 cells, not necessarily that interesting. The connections plot. So this shows the strength of connections between populations. And E to I has some, E to E has nothing, I to E has some, and so on. We can look at our traces. Oh, no, excuse me. We haven't launched it yet. I'm sorry. So let's click our rocket to launch the simulation. You can see the connectivity and stuff without running the simulation, but you can't see the data without running the simulation, the traces. And give it a few seconds to run. There we go. Okay, so now let's look at the traces. All right, and we've recorded cell 0 from the excitatory population and cell 2 from the inhibitory population. And you can see the interplay here in inhibitory cell spikes. It causes the excitatory cell to lose the spike. Very, very simple network. So the raster plots, not necessarily all that interesting. Spike histograms. The power spectral density to frequency, how much power at each frequency, and so on. Granger won't do anything here. And yeah, so this is just to show that you can load morphologically detailed models, import them if you want to, or yeah, we have some available already. You can look at each section, you can adjust everything, run them, and perform all these analyses very simply.